Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Decipherment by Nicholas Duhale. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. A gray line can be split into one or more overlapping segments, each summing to 10. Um, so, as an example, this could be broken up many different ways into adding up to 10. We could have something like 1, 2, 3, 1, 3. 8 and 2, and then 4 and 6. So the gray line can be split into one or more non-overlapping segments, each summing to 10. This is 1, 2, 3, 1, 3 adds up to 10. 8 and 2 adds up to 10, and 4 and 6 adds up to 10. So basically, every line adds up to a multiple of 10, and it has to be divided evenly so that every segment can be broken is adding up to 10, essentially. So that's how these gray lines work. We have a digit in a yellow circle indicates the number of odd digits which appear along the attached line. That's actually, that previous example wasn't going to work, but let's try this. 1, 3. That's currently 1, 2, 3, 4. So let's have 6 there, 4 there, and 3 and 7 and 3. I think that works. So a digit in the yellow circle indicates the number of odd digits which appear along the attached line, and a digit in the blue square indicates the number of even digits which appear along the attached line. And all such circles and squares are given. Well, okay, so this doesn't satisfy that, unfortunately. But if you count the number of odd digits on this line, you have 1, 2, 3, 4, 5, and 6, which matches the 6 in that circle. You also have 1, 2, 3 even cells on that line. So that would match that. And unfortunately, this doesn't actually work because all such circles and squares are given. So you would have to have a square there and a square there for this to be a valid line. Because, yeah, it basically must match the correct... Anytime it does match, you must have the square or the circle be there. So, anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So if we have a square and a circle on the line, those two digits must add up to the length of the line. So this must add up to 3 here. And it can't be 0, 3, so it must be 1, 2 as a pair. And they must add up to 10 for every segment, or a multiple of 10 for the whole line. So this would have to be 7. Therefore, there are 2 odd digits, which the yellow circle indicates, and there is 1 even digit. Okay. This line is 1, 2, 3, 4, 5, 6, 7 in length. So these two digits must add up to 7. We can't have 1 here. So that means we can't have 6 here. We can't have 6 even digits. Which makes sense, actually, because if you had 6 even digits, you would have 1 odd digit, and the sum of the line would therefore be odd when a multiple of 10 is always going to be even. You have something similar here. These must add up to 9. Let's do this one first. It adds up to 5. So this is 1, 2, 3, 4. So this necessarily adds up to 5. You could have, so this could either be adding up to 20 or 10 on this line. You just don't know which. For even digits, it's either going to be 1 or 2. We don't know which, because the thing is for 3 digits, because you can't break down a 3-cell line into 2 and 1 with one of them adding up to 10. Or both of them adding up to 10. Because that would then be a single digit adds up to 10, which is impossible. So it must be 3 digits here adding up to 10 here. And if we tried to have 3 here, the problem is that that's already 1 odd digit. So this must be either 1 or 2 here. These digits so these digits have to be the same digit, and these 2 digits have to be the same digit. And they must add up to 7, because this line has 7 on it. This must be 5 at most. Can you have 5 odd digits adding up to a multiple of 10? The answer is no, so this is 4 at most, actually. It can't be 1 either. If it's 1 odd digit, you have the rest are even digits, which means it adds up to an odd sum. And the same with 3. 3 odd digits gives you 2 even digits, but 3 odd digits will add up to an odd sum with the 2 even digits, which you can't have a multiple of 10 come to. Yeah, so you can't have 6 odd digits here. That would no, you can't have 6 odd digits. You can't have odd digits. So if you have 3 odd digits here, you would have 4 evens, which is not allowed, because then that would add up to an odd sum, and same with 5. So no 3 or 5 here, which means no 2 or 4 here. You cannot have, so similarly here, if you had 1 odd digit, you would have the rest be even. So that's not going to work. So this must be not 1 and 3, it's 2 and 4. That means this can't be 2 and 4. Let's color these as odd and evens. So this is odd, this is even, this is odd, this is even, this must be odd, this must be even. Yeah, all the circles, all the odd circles, which are yellow, have to be even on these lines. Because if they're odd, then the sum would have to be odd. And all the evens all the blue squares must be odd. So this must be odd, this must be even. These are even, and these must be odd. You can't have 2 evens here. If it's 2 evens, then it's going to add up to an odd sum. So this must be odd, which makes that a 1. So all the squares have to be odd here, and all the circles must be even. That's interesting. So this has to be 2, 4, 6 here. 2, 4, 6. This is 2, 4, 6, 8. This is 1, 3, 5, 7, but cannot be 1 because of 1 in the row. So therefore this can't be 8. This is 135 and 135 here. This can't be 1 because of 1 in the row. This can't be 1 then. So to add up to 7 here, it means this cannot be 6. So no 6 here. We have a 2, 4, 6 triplet. We have a 2, 4, 6 triplet in box 3 in column 8. That eliminates 2, 4, and 6 in the rest of the box in column. So it has to be, then we have 3, 5, 7, 9, and 8 remaining in the column. Same with the box. It's 3, 5, 7, 8, 9, and then we have 1 available. Okay, so this cannot be 9 or 8 because this must add up to 10 or less. It can't add up to greater than 10 because then that doesn't form a segment which adds up to 10, non-overlapping segment. So no 8 or 9 there. This has to be then odd, guaranteed. These two could be 5 and 5. That could work. 7 eliminates 7 in the rest of this row. These two digits we have one even digit here. So it's 2, 7, 3, 6, or 4, 5, adding up to 10. This definitely adds up to 5. So this cannot be greater than 5. So it's 3 or 5 there. So it could be, can it be 5 plus 3 then here? And then another 2 digits to add up to 10? No, because then that would be 2, with 2 digits trying to add up to 10 with them both being in the same box. I think this has to be 5 then. And then these 2 digits must add up to 10 here. You can't have 4 digits adding up to 10 and then a singleton digit adding up to 10. So this must be 5 and 5. That means this cannot be 4, 5 as a pair adding up to 10. There's no more 5 in the column. This could still be 5 and 5. In fact, it's getting more likely to be 5 and 5. This cannot be... It could be 2 odds, so this is odd. So we know these two add up to 10. So it's either 1, 9, 2, 8, 3, 7, or 4, 6. 1 can't be here, so 9 can't be there. Uh, 5 eliminates 5 here, which means this can't be 2 to add up to 7. Therefore, 2 is guaranteed to be one of those 2 digits there. This cannot... No, it could be 2 and 8. Hmm. Hmm. Um, remaining digits of box 6 are 1, 3, 5, 7, 8, 9, 6, 7, 8, 9. Again, this cannot be 9, because then this pair would add up to greater than 10 guaranteed. um, hmm. So this digit is the same as that. We have a 6 guaranteed in one of these two cells. Well, that's interesting. This digit has to be one of these two. We have a 2, 4, 2, 4 pair in row 5. So then that leaves that as 1, 3, 5, 6, 7, 8, 9. No 1 here because of 1 in the column. Can we have 3 and 3 be there? That would force us to be 4 and 4. 3 and 3, therefore, would have to have... How does that work? 3, 3. You can't have another 4 here, because that would be 2 and 2. You can't have an odd digit here, because that's the last odd digit on this line. Or, sorry, wait, hold on. It's 3 even digits. Uh... Never mind, you could have 2 odds. How would that work, though? 3, 3. That would mean 4 and 4 here. But you can't have you can't have a 4 here, because you already have 4 there. So 3 and 3 adds up to 6. You have to have evens, because you can't have... you can't have a 4 here. You can't have 2 odds, because that would require 1 and 3 on this line, and we already have the 3 alls accounted for on this line, because every square is given. So you can't have 3, 3, 1, 3. You could have 3, 3, 2, 2. You can't have 3, 3, 4. You could have 3, 3, 2, 2, but then that's 4 evens already on this line, when we're supposed to only have 3. Therefore, this cannot be 3. This has to be 5, 5 as a pair. The circles then must add up to 7 with the squares. So that's 2, 2. That means we have 2 odd digits and 5 even digits. So the rest are even. No more 1, 3, 5, or 7, so it's 6 or 8 there. This 2 eliminates 2 here, so that's 4. So this must be 4 and 1 here. So 1 even digit, which means the rest are odd. We have 4 odd digits here. So no 2, 8, no 3, 7. You can't... Sorry. No 2, 8, or 4, 6. And you can't have... What did I just do? 2, 8, no 4, 6. We can't have a 1 on this line, because that would have to have a square around it. So this must be a 3, 9 pair. Sorry, 3, 7 pair here, then. 2 eliminates 2 here, so that's 4 odd digits, which means all the remaining digits are odd. This must add up to 10. could we have 1, 3, 1, 3? Well, no, we can't have a 1 here at all, because 1 would signify the number of even digits, and it would have to be given. So this, I think this has to be 3 and 3 here to add up to 10. And then this must be a 3, 7 pair here to add up to 10. That eliminates 3 and 7 in the rest of column 5. 2 eliminates 2 here. So to add up with 4 and 6, this can't be 7 anymore. It's 3 and 5. This can't be 5, because 3, 5, and 4 at minimum adds up to 12, and 3 and 5 adds up to only 8. So this can't be 5. 4, 3, and 3 add up to 10, plus 3 and 7 add up to 10. We can't have a 1 there because that signifies how many even digits there would be there on that line. This can't be 2 or 4, so that's 6 or 8 also. And this can't be 2, so this has to be 4, 6, or 8. Well, these have to add up to 10. Or less. And it can only add up to 10, so this is 4 and 6 there. Therefore, these 3 must add up to 10, and therefore this must be 6. So that eliminates 6 in the rest of the box. No more 1s here either. 1 eliminates 1 there. We know these two add up to 9. Can we ever have a 3 here? If we have 3 here, this becomes 5, 3, and 4, which adds up to 12, and this is only adding up to 8, so that's not going to be a segment that adds up to 10. So this can't be 3. It could be 3 and 7 here, and that would work fine, and this is 6. Or this is 5, 1, and 4, adding up to 10. That is possible both ways. 1 eliminates 1 in the rest of row 5. 3 eliminates 3 in the rest of these box here. Okay. 5 eliminates 5 in the rest of this column and column here. 6 eliminates 6 in the rest of this box here. So one of these two digits is a 6. Right, we have 1, 2, 7 adding up to 10, 4, 3, 3 adding up to 10, 3, 7 as a pair adding up to 10, 1, 4, 5 adding up to 10, 2, 6, 2 adding up to 10, 6, 4 adding up to 10, 5, 5 adding up to 10. Hmm. 2 has to be one of those two digits. You could also have technically, well, you could technically have 3, 7, 4. No, that's not gonna work. 4 has to be with 5, and 6 has to be with 3 here. So 4, 5, and 1 add up to 10, or 6, 3, and 7. 3 and 7 add up to 10, and you'd have 6 there. 3 can't be here because of 3 in the row. Hmm. Let's see. One in box 4 has to be one of these 3 cells because it can't be here and here. 3 is one of these 3 cells. 2 cannot be here, so this can't be 7 there. 2 is one of these 3 cells. 4 and 6 are both here, so 4 has to be one of these 2. 6 cannot be here because of 6 in the column, so this can't be 3, which means one of these 3 is a 6 here. Remaining digits in box 8, we have 1, 2, 6, 7, 8, 9. Or 1, 2, 6, 8, 9, sorry. No 1s here because of 1s in the row. No 6 here because of 6 in the column. Hmm. Remaining digits of column 5. We have 1, 2, 5, 6, 8, 9. No 6 here because of 6 in the box. No 2 here or 2 here because of 2 in the row. What digits can be here? It has to be less than 6. 6 or less, I should say. Because it could match this. It has to be at least 10 or less, essentially, for these two to sum up. So it's 1 through 5 because it can't be 6 because of 6 in the column. No 2 here because of 2 in the row. Therefore, these 3 digits must add up to 10 or less. Because if they... And this can't be 3 because of the 3-7 pair in the box. Because if they don't add up to 10 or less, then this is never going to be a segment that adds up to 10. This is at minimum 1 and 4. So we could have 6 and 4 here. Actually, this is not guaranteed then. We don't have necessarily these 3 adding up to 10. It could be 6 here and 4 there. That's fine. Wait, does that even work? If we had 6 here and 4 here... Sorry, if we had 4 here and 4 here... That could work. You could have 1 and 1. Can you ever have 6 here and 4 here? Can 6 ever be here? If you have 6 here, you could have 4 here, but there's 6. The 6 in the circle means there's 6 odd digit, which means there's 1 even digit, which means that's not going to work as 6 and 4. And can we ever add up to 10 with this without these being odd? Sorry, with this both being odd. Because 6 would require that. And 6, there's no 3 here, so it'd have to be 1 and 5 at minimum. And that adds up to 12, which is too big. So we can never have 6 here, which means this is 4, this is 6, this has to be 3 and 7, adding up to 10. That eliminates 3, 7 in the rest of the box. And where's the 1? It has to be here. 1 eliminates 1 here. This can no longer be 4, 4, and 1, 1 here. So this has to be 4, 1, 5 to add up to 10 or less. Can't be 4, 5 because 4, 5, and 6 adds up to 15, and 4 and 5 add up to 9. So this must be 4, 1, and 5 there, which are both odd. We have 3 evens here. Oh, so this is 4, which makes that a 3 there. That eliminates 3 in the rest of the column. 3 can't be here. 3, 7. We have 3 evens. So we could have 6. This is 1, 2. Can't be 1 or 4. So this has to be 6 and 4 to add up to 10. Because 1 and 3 are not available. It has to add up to 10 or less for these 2 digits. So then it can't be 6, 2, and whatever, because 6 and 2 only add up to 8, and 6, 2, and 5 add up to, at minimum, 13. So this must be 6 and 4. That's 2 of the evens here. These 2 have to add up to 10 or less. 5 eliminates 5 here. And this cannot... Well, it could be 8, 1, 1. That is potentially possible. But that doesn't really work. 5 here eliminates 5 here. No 1. 5 eliminates 5 in the rest of the column. We have 2 evens somewhere here. Doesn't this have to be 8 and 2 then? So can it be more than 2 digits adding up to 10 here? You could have 3, 1, 6, but then the problem is this is by itself and cannot add up to 10. Can you have all 4? The answer is no. This is at minimum 3, 1, and 6. Which again adds up to 10 already. So this must be odd and odd. Therefore, this must be even and even left on this line. So this must be 3 and 7. And this must be, can't be 4 and 6 because of 4 in the box. It's just 8 and 2. That means where's 6? 6 has to be here. That makes that an even digit. 1 has to be one of those 2, which means 1 has to be one of these 3. Cannot be here because of 1 in the row. 8 eliminates 8 here, so that's 9. 9 and 1 add up to 10. And that's the only way 9 can be on the line. That eliminates 1 and 9 and the rest of the... Ooh, we have a problem here. Okay, where did I mess up? Shoot. I think I'm gonna have to restart this whole thing. Okay, this is 1, 2. So all the odd digits, all the circles... Why is it... That's so weird. All the odd digits, since they're an odd length of line, they have to all be even. Because otherwise it's not going to add up to 10, a multiple of 10. So then these have to be all odd. So therefore we know this is 1 plus 2 and 7 adds up to 10. This has to be 2 or 4. This must be 2, 4, or 6 with 1, 3, and 5 here. These cannot be 1 here, so it's 3, 5, 7 with 2, 4, and 6 here, adding up to 10. This is 2, 4, or... Well, we have 2 odd digits already, but this can't be 1, and these are the same digits. So it's 3, 5 plus 2, 4 here, adding up to... 7. This is 2, 4. It's 1, 3 as a pair. This has to be 1 even digit because it can't be 3. So this is again 2, 7, 3, 6, or 4, 5. We have 2, 4 as a pair there. This adds up to 5 guaranteed. We have 2, 4, 6 as a triplet here. That leaves, what, 3, 5, 7, 8, and 9 left. Again, we know these add up to 5 because that's the length of the line. And it can't be greater than these. The first digits of on a line must add up to 10 or less. If it does not add up to 10, it's going to have to be less. It can't be more. Because then it's never going to form a segment that adds up to 10. So no 7, 8, or 9 here. Again, can we have 5 plus 3 here? And the answer is no. Because that would require 2 for 2 digits in the same box to add up to 2. Or 1 digit adding up to 2 and 1 digit adding up to 10, which is not possible. So this has to be a 5. Still running into the same thing. So this can't be 4, 5 here. 5 eliminates 5 here, so this can't be 2 to add up to 7 there. Therefore... Can we have 3, 3 here? That would force this to be 4 and 4. 3 and 3 only adds up to 6. We can't have another 3 on the line because then it would have to have a square on it. So we can't have 3, 3, 1, 3. We could have 1, 1, 2. No. It would have to be 1, 1, 4. But then that doesn't work. So if we have 3, 3, this is 4, 4. We can't have 3 digits adding up to 10 here, because that would require 4 there, and that would have to have a circle around it. Can we have 3, 3, 4 digits adding up to 10? We can't have 1, 3, but we could have 2, 2. And we can't have these 5 digits adding up to 10, because that would be 3, 3, and 4 already, which already adds up to 10. So it would have to be 3, 3, 2, 2. But this would be 4 and 4 there. And that is greater than 3 evens. So this can't be 3 and 3. This has to be 5 and 5. Which makes this 2 and 2 for odd, so the rest are even. 2 eliminates 2 here, so that's 4. This must then be 4 and 1, so 1 even and 4 odds. And we can't have 1 on this line, because if we had a 1 on this line, the problem is it would have to have a square around it. So this must be 3, 7 as a pair, adding up to 10. This can't be 4, so this is 6 or 8. This can't be 4, so that's 6 or 8. This can't be 2, so we have 4, 6, or 8 there. These must add up to 10 because we have 10 adding up there. This is 10 or less. Well, it has to be 4 and 6, which adds up to exactly 10. So these 3 must add up to 10, so it's 2, 6, and 2 there. 2 eliminates 2 here, so that's 4 odd digits, which means the rest are odd. 7 is odd. No more 2 here, which means no more 7 here. This must be less than... So this is at least 3. We can't have 1 on this because we would have to have a square with 1 around that because there's only 1 even digit on this line. This has to be at least 3, so for this to add up to 10, it has to be 4, 3, and 3. Because we can't have 1 on the line anymore. So no 4, 5, 1. It has to be 4, 3, 3, adding up to 10. And this must be 3, 7 as a pair because we don't have 1 available. This digit, again, these 2 digits must add up to 10 or less. No 2 or 6, so 1, 3, 4, 5, but no 3 here because of 3, 7 pair in the box. Remaining digits of column 5 are 1, 2, 5, 6, 8, 9. No 2 here or here. No 1 or 2 here. No 6 in box 5. No 5 here because of 5 in the box. So it's a similar situation. These 2 digits must add up to 10 or less, so it's 7 at most. No, that's 1, 3, cannot be 2, 4, 6. Plus 1, 3, 5, or 7. Which means this is guaranteed to be odd. Can't be 5 here. 3, 5, and 4 at minimum add up to 12, and 3 and 5 only add up to 8. You can't have 3 here, because if that's 3, this is 5, and then this must be 4, and that adds to 12. So again, we have, 4 here and 5 here, potentially, with that 1. I don't know if I'm making too many assumptions here. Anyways, 2 can't be here, so 7 can't be here. 6 can't be here, so 3 can't be there. One of these is 1. Can we have 6 here? If we have 6 here, that means there's only 1 even on this line, because those are 6 odds. Well, then we'd have to have 6. These would be odd and odd, but they would have to be 1, 5 as most. So this can't be 6, which makes this 4. That makes that 6. This can't be... This adds up to 9, so this must be 3. Oh, you could have 3, 1, 6. You don't have to have 3, 7. That's where I messed up. Okay. Right, so this could still be 1 or 7. We have 4 here. Six eliminates 6 in the rest of this row. Right. Okay, so that's where I messed up. This could still be 1. So I think we did just prove that this can't be 3, 7 then. Hmm. Right, because I had 3, 7 there, that forced that to be 1. Right, okay, so 4 means this has to be 3 here. This must be 7 or less. And it cannot be 2, 4, or 6, so this has to be an odd digit. So it can't be 3. There's no more 3s on this line, or 4s. So it has to be 1, 5, or 7 here. Because of 2 in the column and 4 and 6 in the row. That's 2 odds. Can we have 2 evens here? The answer is no. Six is one of these 2 digits. In fact, this cannot be 1, 2, 3, 4, 5. So this has to be 6 through 9. I think we've just proven that this can't be 3, 7. If this is 3, 7, that would force this to be 1, which means 1 can't be here. So this can never add up to, if we don't have 4, 1, 5 here, it's not going to work, because you get 4, 4, and 5. 4, 5, and 8 is always going to be greater than 10, which doesn't work. And 4 and 4 and 4 and 5, these 2 digits are always going to be less than 10. So it's never going to add up to exactly 10, if that's the case. So then this would have to be 4, 1, and 5, which means 1 cannot be here. 3 can't be here. This is 2 or 4. And 6 plus 2 and 4, it has to be 6 and 4 as a pair to add up to 10. Therefore, these 2, this 5 eliminates 5 here. We have 8 or 9. This is even. These 2 have to add up to 10 because we can't have 4 digits here adding up to 10. Obviously, can't have 3 and 1 adding up to 10. So then these must be even because we have 3 evens on this line. And it cannot be 4 and 6, so it's 8 and 2, which means this can't be 8, it's 9. That means this is 9 and 1 to add up to 10, and we have a contradiction here. Because then we have 1, 2, and 9 eliminated here, so 8 is the only digit that can be in both of these cells, which is impossible. So that's where we get the contradiction. So therefore, we know this can't be 7, it has to be 1 here. That eliminates 1 here and 1 here. So this could be 4, 4, 1, 1. And then 3, 1, 6. That is potentially possible. Or 4, 5, 1 here. We don't know. We do know that this has to be adding up to 10 or less. So I think this has to be 1 either way. Can't be 5. 4, 4, and 5 add up to 13. 4 and 4 only add up to 8. And obviously, yeah, so this has to be 1 here. That eliminates 1 in the rest of the column. So it could be 4, 4, 1, 1. This is odd. Okay, so this digit has to be adding up to... No, this is 10 already here. So we don't have any restrictions there. Just can't be 5. If you have 5 here... Can't be 6 or higher. These 3 add up to 10. Okay, this adds up to 10 here. 4, 3, 3 adds up to 10. 3 and 7 add up to 10. 3, 1, 6 adds up to 10. 2, 6, 2 adds up to 10. 6, 4 adds up to 10. 5, 5 adds up to 10. 1, 4, 5 add up to 10. 3 and 7 add up to 10. 1, 2, 7 or 1, 3, 6 adds up to 10 there. So these 2 at least add up to 10. Sorry, add up to at most 10. So if we had a 5 here, this would be 8 at minimum. That would be 13, which is too big. If we have 7, 7 and 5 at minimum add up to 10, 12, which is too big. So this has to be less than 5, because 6 is already in the box. So this must be 1, 2, 3, 4. No 3 here because of 3 in the row. Okay. So 3 and 6 cannot appear on this line because they would have to have a circle or a square around it. So the remaining digits have to be 1, 2, 4, 5, 7, 8, 9. 5 obviously cannot be any of these digits here because of 5 in the boxes and 5 in the column. This can't be 1 because of 1 in the column. No 2 here because of 2 in the column. No 4 or 7 here because of 4 or 7 in the column. No 1 here because of 1 in the column, in the row. No 4 here because of 4 in the row. No 4 here because of 4 in the row. Oh, that's interesting. Where is 4 in row 4? It has to be one of these two cells. So we're guaranteed to have a 4 in one of these two cells. If 4 is here, then this is no way this is adding up to 10. Right? 4 plus 1 plus 4 and 4. Oh, I guess you could have 4 and 6 there. Never mind. So if 4 is there, this has to be 5. If 4 is here, this has to be 5. So either way, this has to be 5, then. Right? If 4 is here, there's no way 4, 4, 1, 4 adds up to 10. You have to have 4, 5, and 1 there. If 4 is here, this can't be 4, so it must be 5. So either way, this is 5. That eliminates 5 in the rest of the box. These add up to 10, so these 2 or these 4 add up to 10 here. Well, it can't be 4 because 3, 1, and 6 is at minimum. And we have to have 2 evens, 2 more evens on this line. So this has to be even, even. So this has to be 6 or 8, and this 2 or 4 there. Therefore, we cannot, this must be 3 and 7. To add up to 10, that eliminates 7 in the rest of the row. No more 7 here because of 7 in the column. These two digits must add up to 10 or less. So there's no 9 here because 2 and 9 add up to 11 at minimum. This can't be 8. If we have 8 here, that forces this to be 1 and 2 at minimum. And we can't have 8 and 4 here. That adds up to 12. 8 and 1 adds up to 9. 8, 1, and 2 adds up to 11. So 8 cannot be here. Can we have 2 be here? Can we have 4 be here? 4 and 9 adds up to 13, which is too much. 2, 4, and 7 at minimum adds up to too much. It's 13. So this can't be 4. Therefore, these two pair up and add up to 10. These two must be at least, at most adding up to 10. Okay, so this can't be 9 here. If this were 9, that would be 2 at minimum. That adds up to 11. We have 2 more evens and 4 more odds here. these. So we either have, we can't have 3 digits here adding up to 10. So it's either 2 or it's 4. Interesting. Where is 3? 3 eliminates 3 here. Where is 3 in box 5? Can't be on the line. Can't be here because of the 3-7 pair in the column. Can't be on these because this must add up to 10 that way. This must add up to 10 there. And then we have to have only even digits because we have all the odd digits accounted for on the line. So 3 has to be one of these 2 digits, which eliminates 3 in the rest of the row. Where's 3 in box 6? Cannot be here because of 3 in the column. Can't be here because one of these is a 3. And can't be here because of 3 in the row. So 3 has to be there. That eliminates 3 in the rest of the column here. Where is 3 in box 9? It must be one of these 2 digits. Because it can't be here or here because of 3's in the row and column. How does this add up? If this is 2 and 8, the rest of the digits on this line must be odd because we have all 3 evens accounted for on this line. So for these to be odd, how do you add up? Can you have all 4 be odd and adding up to 10? The answer is no. It would be 1, 5. Well, this would have to be 1, 5. That, yeah, you can't. Can you have 2 digits adding up to 10 each? And the answer is no, because it would have to be 1 and 9 here, and 1 and 9 here, which would have a duplicate 1 in that box. So this cannot be 2 and 8. It has to be 1 and 9. That means these are both odd. This can't be 9 anymore. Can you have 4 digits here adding up to 10? Or does it have to be pairs of 2? You could. You could have 5, 1, and 2, and 2 adding up to 10. And that could work. Otherwise, you just then have a 2. Can we ever have 7 here is kind of the question. 7, 1, and 7, 2 only add up to 8 or 9. 7, 8 obviously adds up to 15. That's too large. So 7, 1, and 5 add up to... So this can't be 7. Therefore, this is 2 or 8. So this is even. And we could have another 2 or 8 here, which would force us to be 9, 1. Or this could be 1, 2, 1, 2, 5, and 2 adding up to 10. We don't know. Either way, it just cannot have 8 here. If you have 8 here, how does this add up to 10? It would have to be 8, 2, and 8 here. You can't have 1, 8, 1 because of 1 repeating in the box. Yeah, it just doesn't work. So this has to be 5 or 9, and it's odd. One can't be one of these. One has to be on this line somewhere. But again, it could be 1, 9 here, 2, 8, or 1, 2, 5, and either of these being 1. If this is 2 and 8, well, we could have 2 and 8 there. That's also fine. Where is 7 in this box? can't be here because it must be even. This is filled out. 7 can't be here because of the 3-7 pair in the column. 7 cannot appear in either of these spaces because it just can't have a 7 here because 7 in the row, and this must be less than... Well, this 7 would not add up with 5 or 8 or 9 to add up to 10. So 7 has to be one of these two digits, which means this is a 3-7 pair here. That eliminates 3 and 7 in the rest of the row, so we are left with what? 5, 6, 8, and 9. And this can't be 6, so it's 5, 8, and 9. We have a 3-7, 3-7 pair there, 3-7, 3-7 pair there. 3 eliminates 3 here, so it's 7, which makes that 3, which makes that 7. 7 eliminates 7 there, so it's 3, which makes that 7, which eliminates 7 there, so that's 3. We have 8 3s. We know where the last 3 has to be. It has to be here. So this is 3 and 6. That means... Ones, we know one of these is a 1. One of these two is a 1. One can't be here or here. One of these two is a 1. 2s. We don't have enough information. 2 could be one of those two. 2 is one of those two. 3s we already did. 4s. 4 has to be one of those two. One of those two. Can't be here. It's one of those two. Which means 4 in row 2 cannot be here, can't be here because of 4 in the column, can't be here because of 4 in the box, so 4 has to be there. Which means in column 2, 4 can't be here because of 4 in the boxes, 4 can't be here because of 4 in the row, so 4 is there. Which means this can't be 4, so 4 is there. But we don't have any information here. 5s. 5 is one of these 3. 5 cannot be here in box 3, so it has to be one of those two, which means this can't be 5. So 5 in column 9 cannot be here because of a 5 guaranteed here. Can't be here because of 5 in the box, so 5 is one of those two. Not enough information there. 6 can't be here or here, so 6 is one of those two digits in box 2. 6 can't be here or here, so 6 is one of those two digits in box 8. Well, where is 6? Yeah, where is 6 in row 9? Cannot be here because of 6 in the box, can't be here because of 6 in the column, and these are filled out, so 6 has to be there, which means this can't be 6. 6 eliminates 6 here. Where is a 6 in box 2? It must be here. That means in row 8, 6 is one of those two. In row 1, 6 is one of those two. Okay, so not that much information. Row 2, 7 has to be one of those two. Row 4, because of 7 in the boxes there. In row 4, 7 has to be one of these two again, because of the 7s in the boxes, which means in column 8, where's the 7? Can't be here because we have a guaranteed 7 in column 7 or 9 in box 3 and 6. So 7 has to be one of these two. And 7 can't be here because of 7 in the box here. So 7 has to be here in row 9. And that makes that 2. 2 eliminates 2 here, so that's 8. Which means this cannot be 1, 2, 5, and 2 here. So that means this must be 2 here, 8 and 2 to add up to 10. This must then be 9 and 1 to add up to 10. That makes this 4 and 6 to add up to 10. 9 eliminates 9 here, so that's 8. This can't be 6, 8, or 9, it's 5. 6 eliminates 6 here, so therefore 6 must be here. So this is blue, this is odd. No more 2 or 9 here. It's 5, 8 as a pair. That eliminates 5 and 8 in the rest of the column. So therefore, this can't be 8 or 9. It's 2. 7 eliminates 7 here. Remaining... Oh, we have a problem. This is 2, and we have 2 here, but we don't have a 2 available here. Ah! I keep messing up. How do I keep messing this up? Remaining digits of... Oops. How do I keep messing this up? 2 can't be here, 7 can't be here, so this must be 8. That means this can't be 8 or 7, it's 2. No 2 or 8 there, it's 7. No 7 or 8 there, it's 9. That leaves that as 2. So this can't be 2. This can't be 2. Which means 2 has to be there. No 2 there, it's 4 and 6. No 2 there. So it has to... 8 and 2. Which we have a contradiction here. I don't know where I keep messing up. I think my logic is pretty faulty right now. I don't know what's going on. Okay, let's go back. Before we removed all possibilities here. I do like this. Okay, we had 1, 2, 4, 5, 7, 8, 9. No more 5s because of 5s in the boxes and 5 in the column. No more 1 there because of 1 in the column. No more 5. Move to 2 because of 2 in the column. Move to 4 because of 4 in the column. Move to 7 because of 7 in the column. Move to 1 because of 1 in the row. Move to 4 because of 4 in the row. Move to 4 because of 4 in the row. That means 4 had to be one of those two. That's correct. I think that this logic still checks out. If this is 4, how does this add up to 10 or less? How does this add up to 10? Can we have 4 digits adding up to 10? The answer is no. And so if this is 4, this has to be 5 for this to add up to 10. If this is not 4, this has to be 4, which means this can't be 4 anyways if it's 5. So that's valid throughout. 5 is one of these 3 then. I'm doing such a poor job at this. I don't know what's going on with my logic. My logic's like all messed up right now. This already adds up to 10. We have to have 2 evens here. This is odd. Therefore, we have to have two evens. But, yeah, 316 is the minimum adding up to 10, but we can't have 4 digits here adding up to 10. So it has to be 2 and 2. And therefore, this must be 6 or 8 with 2 and 4. I don't know where my logic's going. I might be missing something really obvious. I don't know if it is. Maybe. No one here, so one has to be one of these two. This is guaranteed to have a 3. We can't have 3 on any more of these lines because it's a square around it. Same with this. And why can't these be... these can't be 3 because of the 3-7 pair in the column. So that leaves 3 having to be there. 3 can't be here, 3 can't be here, 3 can't be here, so 3 is there. That eliminates 3 in the rest of the box. So 3 has to be one of these two. 2 has to be one of those 3. 3 eliminates 3 here, so that's 7 and 3. 7 eliminates 7 there, so it's 3 and 7. 3 can't be here, so 3 has to be there. 7's one of these two. Ugh. We have 3 evens and 6 odds on the main diagonal line. We have 8 threes. This keeps coming back. 3 and 6. Yeah, I think the mistake must have been earlier. But I don't know where. Well, we still technically have a 7 possibility there. 7 eliminates 7 here. Man, I'm just... Yeah, I'm so... Excuse me. Oh. I think I spot it. It could be 2, 1, and 7 there. That might be what I'm missing. Huh. I think that's what I'm missing. Yeah. 3 digits adding up to 10. Totally forgot about that. And then you could have 1, 5, and 4 here. Huh. Okay, we can't have 8 here, though. Again, we have the same problem. So 2 could be here with 8. 9 could be here with 1. Those are perfectly fine. But we forgot that we could have 2, 1, 7 there. And that's looking like it is the answer there. We can't have 8 here. 8, 1 adds up to 9. 8, 4 adds up to 12. And 8, 1, 2 adds up to 11. So there's no combination of digits with 8 there adding up to 10. We can't have 4 here. 9 and 4 add up to 13. 2, 4, and 7 add up to 13. 2, 4 adds up to 6 by itself. 7 can't be here. 2, 7, and 8. 2, 7 adds up to 9. 2, 7, and 8 add up to 17. 8 and 9 don't work. 2 and 9 add up to 11. 2 or 8 could work, but it can't be 9. But we tried 9 and 1, and that does not work. Oh, we know this is 3 and 7. Oh, well, okay. So 7 has to be here, which means we again have the same scenario, though, but this time we don't have anything stuck there. So that's good. 7 and 7 could be here. 7 and 7 could be here. We cannot have... Okay, so where's 7 in column? 8 cannot be here because of 7 in the row. Can't be here because of 7 in the row. So this must be a 2-7 pair here. Okay. That means the rest of column 8 has to have 5, 8, and 9 as possibilities. The rest of box 9 is 4, 8, and 9. And we can't have 2 and 8 here. That's all the evens in this box, so these would all have to be odd. And we'd have to have 1, 9, and 1, 9 being there to add up to 10 for these sets. You can't have 4 digits adding up to 10. You can't have 3 and 1 adding up to 10 each. So this cannot be 2 and 8, but we do have that as a 1. 1 then has to be one of these two. 1 can't be here, so 1 is one of those two. We got all the 3s accounted for. 7s we have a lot of. This can't be 7 because of 7 in the row. 7 can't be here or here. So 7 has to be here, which is odd, which means this must be 2, 1, and 7 to add up to... You can't have 7, 1, and whatever, 7, 2, or whatever, because that's too large. And 7 and 1 and 7... So 7, 1 adds up to 8. 7, 2 adds up to 9. 7, 8 adds up to 15. 7, 1, 5 adds up to 13. So if we try to have 9 and 1, that's not going to work. So this must be 2. So that's where we get. That's 7, which makes that 2. Okay. Where is 2 in row 8? Cannot be here because of 2 in the boxes, so 2 has to be there. That eliminates 2 in the rest of the column. So this is a 5, 8, 9 triplet, which eliminates 5, 8, 9 in the rest of the box and column. So this can't be 8 or 9, it's 6. This can't be 8 or 9, it's 1 or 2. And this has to be 3 digits, adding up to 10. Well, 8 and 9 with 2 other unique digits are not going to add up to 10. So it has to be 5, 1, and 4. So this is 5, that's 4, and this is 1, which makes this 2 and 8. No 5 or 8 there, it's 9. That means this is 6. 5 eliminates 5 here. Ugh. I did such a bad job on this. This was, I don't know why, I just kept on messing up. 1 eliminates 1 there, so 1 is there. 1 eliminates 1 there, so that's 1. 2 in column 3. 2 can't be here or here because of 2 in the column. 2 can't be here because of 2 in the row, so 2 has to be there. That gives us 8 2s. We know where the last 2 has to be. It has to be there. We have all the 3s. 4. In column 4, 4 can't be here because of 4 in the boxes. Can't be here because of 4 in the row, so 4 is there. In this up box 1, 4 can't be here or here because of 4 in the top row and column. 4 can't be here because of 4 in the row, so 4 is there. In column 2, 4 can't be here because 4 in the boxes, 4 can't be here because of 4 in the row, so 4 is there. And that gives us 8, 4, so the last 4 has to be there. 5. Where's 5 in box 4? Cannot be here because of 5 in the column, so 5 is there. Where is 5 then in row 4? Cannot be here because of 5 in the boxes. Can't be here because of 5 in the column, so 5 is there, which makes this 7. That eliminates 7 here, which means this has to be 7 there. We don't have enough to disambiguate the 5s here. 6s. Where's the 6 in column 4? Not here because of 6 in the box. Can't be here because of 6 in the row, so 6 is there. Where is 6 in row 1? Can't be here because of 6 in the boxes. Can't be here because of 6 in the column, so 6 is there. That leaves us a 6 there. As 8, 6, we have 8 6s. 7s we've finished. And now we have potentially 8, 9 pairs. This must be 9 because of not. That's the last digit in the column. That makes us 8 and 9 there. That leaves that as 8. 8 eliminates 8 there, so it's 9 and 8. 8 eliminates 8 there, so it's 9. That leaves 8 remaining in row 2. 8 eliminates 8 here, so it's 9, which makes that 8. That eliminates 9 there, 8 there, so it's 9, which makes this 8. 8, that forces this to be 9 and 8 there. 9 can't be here. Can't be 8, so this must be 5, which makes that 9. This can't be 8 or 9, so it's 5, which makes this an 8. I did that so badly. I was not, I don't know. I wasn't completely here, I guess. I just wasn't, just didn't do a good job. Apologies for that. I've made way too many mistakes here. It was just pretty bad. Yeah, it should be average difficulty or challenging difficulty. But I don't know. My brain was just not, just wasn't working very well. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.